Hi, my name's Rush, and in this video we'll be looking at the polar and rectangular representation of a sine wave. Firstly, a sinusoidal wave is obtained from tracing the circumference of a unit circle by tracking the motion of a point C at angle theta with coordinates x and y around the circle. In AC circuits, this is used to represent the amplitude, either showing the voltage or current, as functions of the time t, which is given by the general form A sine omega t plus theta, where A is the max amplitude of the wave, omega is the angular velocity, which is given by the formula 2 pi over t, t is the time, and theta is the phase shift of the waveform. For the purposes of demonstrating calculations and conversion between forms, I'll be using this example of 5 sine omega t plus 30 throughout the remainder of the video. The first form this sine wave can be converted into represents the sine wave with a direction and a magnitude, which is polar form, given by the general form c equals r angle theta, where the magnitude r of the sine wave is given by the root mean squared, or the RMS value, in which the amp is divided by root 2, to get the magnitude of the sine wave in polar form. And the value of theta in degrees remains the same and is given by the value of theta from the sine wave equation. Using this example, we can see that the magnitude r will be equal to 5 over root 2, giving it a value of 3.5, and the theta will simply be 30 degrees to give a value in polar form of 3.5 angle 30. Now, once in polar form, multiplication and division operations are especially convenient, as seen where multiplication is simply multiplying the two magnitude r's together and the summation of the theta values, where the two magnitudes in this example of 2 and 6 are multiplied together to give a resultant of 12, and the two thetas of 20 and 35 are added together to give a resultant angle of 55 degrees. And similarly, division is just the opposite process to this, where the first magnitude is divided by the second, and the second theta value is subtracted from the first. Now, the sine wave can also be represented by an imaginary number, which is done through conversion to rectangular or Cartesian form, which is given by the general form c equals x plus jy, in which the same point c will contain an x coordinate given by r cos theta and a y coordinate given by r sine theta, where the values of magnitude r and direction theta are substituted in from the previously obtained values from polar form. And as can be seen here, the graph resultant that was obtained from these values matches up exactly with what was graphed in polar form. Now, conversely to polar form, addition and subtraction operations are especially convenient in rectangular form, which is simply the addition of the real x components and the imaginary y components, as seen in the example where the real components of 5 and 11 are added to 16, and the imaginary components of 3 and 2.5 are added to 5.5j, for a resultant of 16 plus j 5.5. Now finally, conversion from rectangular to polar form is done through basic trigonometry, in which the magnitude r, being the unit circle radius, the distance from the origin, and also the max amplitude of the sine wave, is given by the equation r equals root x squared plus y squared, which is derived through simple trigonometry from the unit circle equation r squared equals x squared plus y squared. And the direction theta in degrees is equated simply by tan inverse y over x. And as seen here, working through this process with the values obtained in rectangular form gave the exact results obtained previously in polar form.